Okay. So, welcome to the panel. If you're brave enough in the audience to attend, come forward. It's like an empty auditorium, and then so if you're sitting over there, please take 2 minutes to come forward, and then we can have a nice interactive conversation. If I can entice you to get up, and if you're not on the front 3 rows, move to the front 3 rows. I promise you, it'll make for a better conversation. Come on. It's like, Okay, so we structured the panel assuming the audience would be larger, and some of these gentlemen are probably not going to speak to me again, but that's a different story. But they've put a lot of thought into it. One of the things we can do is just make it much more interactive. There are 2 mics over there. We have about, 20 slides? Yeah, we have about 20, 25 slides, but if you interrupt us, we won't get through all of them, so that's the good news. So feel free to interrupt any of us at any time. The rule is you all sit up front, so if you're coming in, please. No, the first 3 rows isn't up front. Come on, come the first 3 rows. Okay, so we're doing a panel on collaborative silicon development. We've got some really distinguished panelists. Where's DJ when you need him? Okay, oh yeah. So anyway, he had this nice one line. I didn't know where it came from, but the basic theme here is, open is the mechanism you build something beyond the scope of a single company as a group. And we've got Brian Allison from IBM. And a lot of involvement in CAPI and OpenCAPI. Then we've got Kevin from Facebook. Is engineered across hardware and software and all sorts of everything in between. We've got Mr. AIB, Dave Kellett from Intel. It was like one of the few guys I know was moved all the way from like managing large teams to going back to being a research scientist, which is like a pretty nice achievement. And we've got Mark Kemmerly from Avera. The awesome news is we pushed out a Bose spec today, so that's really nice. And so he builds like a wide range of high-performance ASICs. So that's our group. Yeah, this is going to be a long hour if there are no questions. I can tell you that right now. So the interesting thing is I was cataloging what happened in 2019, and this is, I'm sure I missed something, but this is a list of open hardware announcements just in 2019. There's of course, it was near and dear to us, which is the ODSA was announced in March. Then Microsoft released RTL for Zipline. The CHIPS Alliance happened in March. I guess there's something about March where announcements go. In June, there was a announcement for the Open Hardware Alliance from Canada, building like a multi-core RISC on fully silicon verified with a regular off-the-shelf design tool flow. And finally, in August, IBM open source the power instruction set. I have to be very careful when I say that, apparently, what got open sourced. So, actually, we're a smaller audience. If you're here, you already know about all this, so we can skip this. All right, so the idea we had for the panel today was that the core had, so the rule is you have to sit in the first 3 rows if you're brave enough to come in here. So come forward, so you can ask more questions. So the idea we had today was that the instruction sets have received enough attention. What needed attention was the rest of the chip, the uncore. And how do you collaborate on everything uncore? I/O, caches, cache controllers, network I/O, you name it. That's the basic theme of the panel. And so the interesting thing is we did the version of this panel at our ODSA workshop about 2 weeks ago. And these were the questions that kind of came up during the panel. So we assumed that, in case there was a larger audience, it's like we'd have some structure to discuss, but these are the questions that came up. So what we're going to do is have each of our panelists report on the homework they did on these topics. I'm hoping you will interrupt everyone while they're speaking, so I'm really hoping someone has a question right now on whether this is a good agenda or there's something else you want to discuss. If not, we will go to Kevin, and I will be your clicker.
Okay, next slide.
So does anybody have any questions, just to get us rolling on the right foot? Whoever asks the first question really sets the tone for the hour. So if somebody is nice enough to get up and ask the first question, or should, yes. Please. There's mics over there. And
so I can understand why the open software was important to be implemented or started, right, by the other companies. But why is it that the open hardware, especially at the level of the chipsets, is important to be open?
Oh, okay. So Kevin, do you want to answer that before we get into your slides? Or? Thank you.
I suspect each of us has a slightly different perspective on the answer to that question. I think if you look at the evolution of the industry over the last several years, or last several decades, the cost of developing silicon continues to grow exponentially. As you chase each semiconductor process node with your mixed signal IP, your memories, your standard cell libraries, that investment grows with each process shrink. I think we also see that certain process shrinks hinder the ability to do certain functions. For example, mixed signal functions run typically better at some of the older technology nodes than in technology nodes that are now optimized for logic. The transistors are noisier. It's harder to make the interfaces robust. That alters the power performance area equation, PPA equation. A chiplet ecosystem actually solves some of those challenges. I think it also introduces new challenges. Why does Facebook care?
Yeah, I didn't plant that question.
Right in the gunfire there. We believe. Sorry, go ahead.
Please go ahead.
Yeah, we believe this is an important problem to solve. Obviously, Facebook is a consumer of many silicon products. There's an investment in accelerator technology, which is very important to Facebook. Facilitating an ecosystem that allows a larger number of participants is obviously advantageous. So.
Anybody else want to?
Imagine it's a cost equation problem, right? I mean, you don't have the skill sets and necessarily want to invest in every single one of those. Mm-hmm. So if the ecosystem can broadly, nurture it and get to a certain maturization point, I think everybody benefits, yeah. Right? And absolutely. I think you try to be not biased, right? I mean, you're trying to be open to everybody, and whoever has the best technology or, can bring the most to the table, you're going to take a serious look at them and potentially adopt them, right? So I think that's everybody's vested interest to, invest in the ecosystem together, because I think everybody has unique skill sets and things that they can bring to the table.
You can reduce the interval from concept to production product. That advantages the entire industry.
That's huge.
Including Facebook.
Yeah, because it's changing quite dramatically, in my opinion. The durations of those intervals are shrinking, right? Yeah. Because the problem sets are getting more challenging every year, right? And if you wait on a 5-year cadence, that's just not going to cut it. So.
Yeah, I think I would just add that there are areas that you want to monetize. This is your core capability, and there are areas that you don't, that you want to use to enable other folks to interoperate with you. Mm-hmm. And those areas are great ones to open source because it reduces barriers for development.
Yeah, I would definitely have to second that, David. There's so much drive, I think, in our industry towards chiplet-based systems. I think it's starting with people who have too big of a problem to solve, and they have to break it into these different chiplets so they can make something happen. And I think a lot of us right now are seeing chiplets as inevitable. Once you recognize that we're going to get to chiplet-based architectures, it really becomes critical that all of these things have a way to talk to each other. So without collaborating across the industry, we're just going to end up with massively complex systems. If there's some collaboration to define how everything interacts, we end up with much more efficient systems, and you've got a lot more freedom to build the chip that you want to make.
Or the stuff that matters to you.
Yeah.
Right? If you can standardize the interface and create chiplets out of that, right, and then care about the problems that you have, that you really care about and can actually differentiate yourself in, that's how you want to invest your time, not on some of these, standard interfaces that, could be just solved by everybody.
Yep.
Does that make sense? Yeah.
Yeah.
You asked the question, so.
Are you happy with our answer?
So I think we owe Peter a huge thank you for getting us started with a nice question. Thank you. So Kevin, I'm going to go through your slides, and if you can interrupt Kevin whenever you want to, especially if you're from Facebook, then we're in good shape.
So before I jump into this slide, I just want to say we're very excited by the momentum happening around ODSA. We see this as a necessary evolution of the industry. So to facilitate the creation of that ecosystem, there are several areas that we perceive need to be resolved in a way that lowers the barriers to entry for the ecosystem, for participation in the ecosystem. One of those areas is the business model. This is something that we continue to talk about within the ODSA meetings. Developing a sustainable chiplet business model that yields profitability for the chiplet suppliers, the consumers of those chiplets, and the SIP end users is absolutely critical for the ecosystem to develop and become sustainable. We often talk about what are the other analogous ecosystems that are out there. One consideration, and this is by no means the only consideration, but one consideration would be, is a chiplet business model an evolution of the IP business model, whether that be hard IP or soft IP? Can we look at that part of the industry, which is very well studied and very well understood, and leverage what we know there to develop a chiplet ecosystem? From a funding and revenue model perspective, can we extend the IP development and IP supply industry to chiplets using similar funding and revenue models? I think the caveat there is if I deliver a piece of hard IP, a SerDes, or a piece of soft IP, the protocol layer controller,
The heck?
delivering a chiplet, you're delivering the ultimate hardened IP, right?
This will make it a little more challenging.
Yes, it makes it significantly more challenging. So for this ecosystem to be successful, we believe it needs to be open. It needs to be collaborative. Do you want me to keep going, Bobby? Or?
Yeah, I think I'm out of juice at the wrong time.
Beyond the business model?
I think I'm at bar.
Sorry, go ahead.
That's it, keep going.
Okay,
If you can.
Good thing we all have our charts memorized.
Yes, yes.
we've gone over. Yeah, I think I'm. Anybody have a laptop I can borrow?
Not with me.
I've got everybody's.
You're doing so well. You have your presentation on a stick.
Nope,
was on a
I'm going to.
You're right.
Well, it's a good thing we're like. So, so the business model, and then your next slide. Do you remember?
My next slide, do I remember? I think in the interest of time, let me cut to where we see significant importance in openness in the ecosystem. If I want to lower the barrier to adoption to developing a SIP, I need to look at every dimension of that development. If I'm talking about from concept through to physical design and actual manufacturing test of a SIP,
Unbelievable.
Sorry? Yep. We perceive the need to have a common set of deliverables that every chiplet vendor signs up to provide. If I want to simulate my SIP, I'm going to want a System C model of each chiplet or a UVM model of each chiplet. If I don't get that piece of IP, or a chiplet developer doesn't get that piece of IP, they now have a hole in their flow that they need to add investment to patch. And that diminishes the potential value add of an open chiplet ecosystem. When I integrate all these devices together, all these chiplets together, how do I actually test that package? How do I test that SIP? I think if you talk to any two semiconductor vendors, they will tell you about their DFT flows and their testability flows. And today, those are probably very different, or different in slightly incompatible ways between vendors. I believe Mark is going to talk more about testability in his presentation. If I talk about how to actually integrate those devices together, how do I provide information that can be utilized across an EDA toolchain, having an open common standard for all those deliverables will not only facilitate integration at the chip level and make SIP development easier, and I don't think anyone sitting here thinks it's easy, thus the quotes, but having common data exchange formats, which some of our partners in the ODSA are developing, brings other participants into the ecosystem, the EDA vendors perhaps, to develop tool chains that can move data between different parts of the flow. I think for SIP integration to be easier, it requires an open ecosystem, and that requires standardization or having common standards across most of the flow. We can jump back to my previous slide, or in the interest of time, keep going. I think common interfaces is something we talk about very, very often in the ODSA calls that we participate in. If we fail as a team to come up with common interfaces, you could foresee a fracturing of the ecosystem. As I go to purchase each of my chiplets and integrate them together, if I don't have common die-to-die interfaces, it will hobble, or it will prevent the barriers of entry to being lowered. I think some key examples, if I extend that IP analogy I started talking about previously, if I extend the IP industry analogy, if you look at the pipe interface, which was originally developed 15 years ago for PCI Express Gen 1, that interface facilitated separate suppliers for PHYs and for the protocol layer. It allowed me to mix and match the different pieces to build my device. That interface, since it was adopted so widely, is now used by CXL, by USB. We talk quite robustly about using pipe interface within a die-to-die interconnect for chiplets within ODSA. Another example, DFI interfaces. 20 years ago, it was very, very difficult to buy a memory interface controller and a memory interface PHY from different players or different suppliers. Often to integrate those parts together required a lot of extra effort on the part of the integrator. DFI and its successors standardized how controllers and PHYs interface at the memory layer. It allowed you to integrate best-in-class from different suppliers. AXI, probably my favorite in this list of common interfaces, originally developed to connect embedded cores with peripheral IP, has now led to an enormous, massive ecosystem with multiple generations of AXI and hundreds of players within that IP space. So coalescing around common interfaces is going to be very critical for this ecosystem to develop. It's a topic that we spend a lot of time on. So.
Does anybody hopefully have a question for Kevin? So to interrupt him now, or we can come back?
Come on over to the microphone.
Or come on over to the microphone. Oh, all right.
Oh, sorry. Did I sneak up on you?
Nope.
Do you think it's important to standardize the electrical interface or also the physical interfaces and dimensions?
To make sure I answer the right question, can you elaborate on which physical or which electrical interface you're referring to?
So if we're talking about, so from our perspective, we're doing co-packaging of optics. So we're interested in those interfaces to the chiplets, if they're XSR or clock forwarding, all those sorts of things from a electrical interface. But then beyond that, there's some questions about whether we all have to fit in the same box size and things like that. So I'm wondering how you see that.
This is a good question, and there's quite a bit of conversation around co-packaged opticals and how co-packaged opticals relate to ODSA, and that's a topic that we're still discussing. So I don't know that there's consensus at this point.
But I think there's multiple dimensions, right?
Yeah.
I think some people care about like what you're interested in with, let's call it SerDes standardization, right? Then other folks are more interested in, let's call it, the Encore chiplet-to-chiplet internal type standardization. I think you've got multiple camps with their own interests in mind. I think they're trying to solve both, aren't they, Papi, from my understanding?
Yeah, so there's this guy named Ilko from ASE who actually has exactly this thought that maybe you should standardize the actual packaging exactly like so just like you standardize memory on a DIMM, that you can standardize optical I/O on some kind of some kind of a socket, and you can standardize different parts on different physical structures. So yes, the long answer is yes, not the short answer.
Maybe I'll just chime in a little bit on the electrical interface. I think that there are certainly evolving industry standards that will end up being widely used in chiplet-based systems. I've certainly seen over the last year a lot of emphasis for 112 gig XSR serial IP for interconnect. However, I think we've also recognized in the ODSA that we do want to provide a platform for people who might be using technologies where that IP isn't available to have a standardized interconnect between the chiplets. And so as a part of our work in the ODSA, we've been trying to work together with the community to define electrical interfaces that would be easy to implement across different technologies. So there's a lot of discussion about that. I think Bapi shared today that we just released our version 0.7 of the specification that our community's been working on to solicit feedback. So if you have a chance, please go download the spec and let me know how it does or does not address what challenges you'll face in your own chiplet development.
And perhaps I can just chime in here.
Please.
I think the observation was made a while ago that there's a lot of innovation happening at the PHI. You're going to hear from Mark tomorrow about some work he's been doing and some work I've been doing in that area. So one of the areas that we really did think in the near term that we could converge is looks a lot like what we have on our screen now, that could you get the applications to agree at a link layer protocol and have that be kind of the common point while the physical and electrical standardization process occurs.
Yeah.
Just can I ask you the follow-up question on those answers? Is there any difficulties of creating the standard organization that will define those and it cannot be ahead of curve compared to other technologies where you cannot always adapt to new advanced technologies but just be a follower? So at the end of the day, there are some probably big companies can do better things, but other companies cannot just accept those facts.
Yeah, I can certainly speak firsthand through some of the experiences we've had, just even within the small community that has been working on the electrical specification for what we call the bunch of wires. For example, different companies have different access to technologies and different capabilities. One thing we've tried to do in developing that open interface is to take that input so that we could create an interface that could be used for somebody that has access to very fine pitch wiring, but also something that could be used by somebody developing in a 28 nanometer CMOS process using standard package technology. And it is difficult to bridge those needs. I honestly think we've just started to scratch the surface with some good ideas on how folks would have the freedom to develop, either on a silicon-based technology, a silicon interposer or EMIB, all the way to just using a commodity organic laminate. So yeah, it's challenging, but I think there's some really interesting places for innovation and for the community to get together and come up with a good way for chiplets to talk to each other.
I mean, I'd have to agree. I mean, because by no means is this baked. I think we're just like starting.
Just starting.
Right.
Yeah.
So, I mean,
we just threw our first thing out there for everybody to throw tomatoes at. So.
So there's a lot of opportunity for input. Let's call it that.
Absolutely.
Right? So,
absolutely. Yeah.
This ecosystem is going to require a very broad effort and significant participation. If we look at everything necessary to create that ecosystem, today we're focusing on 3 work streams. So that's probably 3 out of a dozen, 2 dozen.
For sure.
But we need support from the community to expand the scope of the effort. So super happy that you're going to join the discussion. Yeah.
So one of the things is we did this panel 2 weeks ago, and honest to God, the first 4 questions were about people who were not on the panel. Where's your test expert? Where's your packaging expert? Where's this other person? So finally we decided, forget it, we're just going to do an entire section on who's not on the panel, and Mark's going to cover that for us.
Thanks, Poppy. Although that's not my chart.
Really?
We went
How did that? Oh, no.
You went back.
You went backwards.
Dave's got his keys reversed.
Oh, yeah.
Okay, so in the last time we had a discussion very similar to this, our audience was very skeptical and very interactive. So we invite you guys to challenge us too. But what came out immediately in the discussion was that we didn't have a specific packaging guy or test guy on the panel. And so today, we wanted to make sure that we address those at least in some way with, certainly from the packaging perspective. I took a total dive on that one, and we're actually going to ask my good friend Wolfgang Salter, who's in the audience.
Sitting right there.
to cover it in a discussion that'll happen, I think, around 11 a.m. tomorrow. So we'd like to have a more in-depth and interactive discussion on packaging in that time frame. So please come back and participate. On test, honestly, this is really one of our biggest needs in our ODSA community. We've just, like I've seen from a lot of the other OCP projects, all of these things start by trying to tackle some of the most fundamental challenges and then grow and build out from there. We've got our efforts on interfaces, on prototyping, and it's like very clear that test really needs to be integral into all of our approaches. It is absolutely one of our biggest problems, our biggest challenges, in the place where we need to do a significant amount of work. So I'd like to use this as an additional format to beg for help. If there's anybody with a test lean who'd like to participate and share your thoughts and ideas in our forum, we absolutely welcome it. I think there's a number of different folks who have solved these challenges based on kind of IP that's held tightly by their companies. If we can come up with really good approaches in our community and put them together with our proof of concept, put them together with our interface work, we can make real progress. I think there's on the next page, there's certainly some starting thoughts on how we approach test. And our goal around test is generally to use the stuff that we've already got on the shelf and that we know how to use. Bridging from Kevin, I think what you shared with us is that there's a lot of things we can take from board level integration and just bring those into chiplet-based integration or chip scale package integration on one laminate. Certainly IEEE 1149.1, 1149.6, we can leverage that infrastructure today with chiplets. IEEE 1500, a lot of different companies have had experience building HBM-based systems, and with more and more experience leveraging IEEE 1500, that obviously becomes something that we would look to leverage in a chiplet-based ecosystem as well. That said, there's a whole bunch of other stuff that we have to figure out, right? Any type of IP that communicates between chiplets is going to have some kind of interest in clocking. We need to figure out how we can calibrate that IP, how we can make sure that everybody's got their PLLs up and running, and all of the communication that goes around that. At-speed test for our modules, we need to figure out solutions for as well, right? Is a chiplet able to come up and test itself? Do we test all the chiplets together at speed? All of these items need addressed, and we absolutely need more and more involvement from the community to help us out in putting together solutions here. I think you got rid of my last chart. Oh, no, you didn't?
Oh.
Okay, cool.
Dave was diligent. He had the latest copy.
Yeah. So some of the challenges that we will have to deal with in test. A lot of good discussion in our last workshop in California. So I'm glad to bring that to this forum in Europe. Fine bump pitches, right? I think some folks in the industry are very comfortable with them. Some folks in the industry are very terrified of them. And we absolutely need to come up with a way for the folks who will use them to be able to test the interconnect. Also, at least in the initial attempt at proposing an interface, it involves IOs that wouldn't be built to drive off module. So these little guys don't have a lot of capability. They don't have a lot of ESD. And we need to figure out good, creative ways so that we can actually test that they're operable. How do we know, what the name tag is on each chip? What device enumeration? How do we figure all those out? So all of these are challenges, and how do we make sure that we understand the kind of errors that we're going to be and how we can correct them? So I pointed out the challenges. They're certainly something that many of us are aware of, but absolutely look to you to give us input on how to approach them.
I don't know whether all of you are. It says please chip in to get
Chip in.
Yeah. Chip in to.
Oh, did I write that?
Yeah.
I didn't mean to do that. I'm glad I'm that funny.
Does anyone want to chip in with a question for Mark?
Uh-oh.
Mark, you've been at this since we got started, pretty close to it. And this is one of the most difficult areas to make progress on and get traction.
Yeah.
When you're talking with engineers that you work with and at other companies. And we've built up a pretty good head of steam as a group here, and there's been quite a bit of outside attention that we didn't necessarily solicit, that just happened to notice.
Uh-huh.
So, I'm wondering if you could just talk out loud for a minute. How's the tone of this when you're working with other people around you on some of these problem sets? How's the tone of the conversation evolved in the last year?
Yeah, it's definitely evolved quite a bit. I think we're fortunate in that a lot of the work that we're doing and a lot of the definition that we're trying to build on, honestly, I think many different companies have realized that a simple parallel interface is a really good solution. Intel did some really fabulous work to define AIB, and to a large extent, we're stealing as much of that kind of background from not only Intel, but other folks who are building parallel interfaces, even from high bandwidth memory, from multiple other sources to just try to come up with something that's simple and straightforward enough that most people see it as useful. There's still plenty of challenges, right? Coming up with a voltage specification, for example, is extremely challenging. Finding something that could be used in multiple technology nodes and what exactly it needs to be compatible with is something that we're still going to struggle with in aligning for the definition. But yeah, I think what we've tried to do is, as people have come in and talked to us about what they see for their future systems and what they need to be compatible. Every time we have a conversation, it kind of shapes a little bit more of what we add to the specification. So my hope is that we can keep making compromises and we can keep coming up with something that'll be useful for as many people as possible. And thanks for that question, Aaron.
Thank you. I just one more follow-up.
Sure.
Dave, would you mind elaborating on that from where you sit?
Why don't you, at this point, maybe restate the question?
I have watched this discussion take place from a few different vantage points, and everybody comes at this with a different list of concerns and a different interest. But I think there was a lot of fundamental resistance to this idea a year ago. There's less resistance today, but there's still a lot of problems. And you have a circle of people you talk to about this and you work with, and some of them are here and they're on board, and others have reservations or reasons, that this is a challenge or it's a tough effort or something like that. I'm just wondering, what's your perspective on the tone of this?
Sure.
Inside you?
Yeah, I think that the idea that we would open up interfaces, that we would join together, that has definitely progressed in the last year, that the interfaces, the work in general is not going to be proprietary, something that people really expect that they're going to make their business model off of. And so that the areas that are in common, I do think there's a increasing openness. It's kind of gone down one level from the top level of could we build chiplets that might interoperate, now down to some of these challenges Mark has here and it's talked about of test, which is now kind of the next level down. And then at each level, particularly test, there are proprietary methods used in testing that people now are deciding, is this something that we're going to keep for ourselves, or is this something that we would say, fine, this is how you deal with fine pitch interfaces, and here's the test scheme for that. So I think we've gone from kind of the larger scale questions of do we want to partner together on chiplets to now, how do we actually do it?
I'd have to agree with that as well. I mean, if you look at IBM specifically, I mean, a year ago, we wouldn't have even had this conversation, right? Not even on our radar. Within the last 3 or 4 months, it's been basically a strategic decision that this is something that we need to participate in. And we've kind of gone, kind of all in with the last couple of ODSA meetings. But, if you would have said this even 6 months ago, I would have said, not there. But I think we're recognizing that this is a problem that we need to be concerned with and something that we need to be involved in. So,
thank you.
You didn't ask me, but I'm just going to dish out an answer anyway. One of the interesting things that's happened is that the questions have changed from the general to the specific. Yeah. So we've had these, should we build an interface, or and now it's more like, why is it 4 gigabits per second and not 8? So and when people are arguing with you about the details, you know that there's some attention being paid. So please.
A question, because you actually started to talk about, I'm glad that you mentioned, by the way, the system C models that you are expecting to have. I'm more concerned also about expectation that the software layer will be ready in a pre-silicon environment, because probably when you think about chiplets, the prime time that the cost will be quite high, so you expect that software to be ready just on even the A0 stepping will be created. So how you see this environment for the firmware and software to be written, to be prepared? Do you have that in mind, or it's too early, or you just want to us to use like a system C models? So how do you see the pre-silicon environment for that chiplet models? So you will create and test quite complex software based on this.
So this is a topic that's very relevant now, as the ODSA work group around the proof of concept has started moving from, okay, well, how do we actually get the chips to talk to each other, to what is the use case and how do we build a software stack on top of 3 products that were originally not conceived to work together. One of the things I think we've learned through that process is the proof of concept PCB, where we've got 3 pitchlets. I'll be very frank and tell you, I have a really hard time wrapping my head around the value proposition there initially. But when you start to talk about software development and you start to talk about how do you invest in a prototyping platform before you invest in the full SIP development, to actually prove that the end product is realizable and build the software stack on top of it. I think what we're learning there is the flows we're developing, the techniques for prototyping, they will all scale forward into a software development model. It's still an area that we're working through and how to successfully integrate, but it is an area of active discussion. So.
Thanks.
And
so
we're always
the slide is incomplete.
No, it's not. I didn't even touch the performance expectations because, for performance analysis, just having the cycle accurate model is not sufficient. You need to have more. So probably it's, you need to grow it, this list.
Yeah. So at our last workshop, there were a couple of engineers from Intel talking about building a system verification model that we're still continuing those conversations that sort of integrates chiplet, soft IP, and software into their simulation environment. I think this was a discussion we had starting June, roughly.
The development of common reference flows for SIP development, EDA tool flows that rely on common data formats to move through the development flow, common sets of deliverables for each chiplet. These are all things that we still need to define, but we recognize the need. So.
Okay, thanks.
I'm glad you mentioned EDA. That seems like under the topic of who's not here. Is there EDA participation?
This is an awesome slide. We're going to flash it up every time.
Yeah, right.
It's like a perfect slide.
Test just screams for EDA. That's a solvable problem for the EDA guys. Right now, from time to time, my company is a consumer of IP and a deliverer of IP. And if our DFT is done in, say, Mentor, and we deliver it to somebody else's, some other company who's in Mentor, piece of cake. Deliver it to somebody else who's in Cadence, it's a pain. And the same thing going back and forth. That seems like a solvable problem, but it would take the EDA guys to help work that out.
Yeah, and I say from an EDA participation point of view, we have had, from a packaging point of view, involvement from EDA vendors like Cadence who've come in and presented to the community what they're doing to enable chiplet-based systems from a packaging point of view. Frankly, as I mentioned, we still need a lot of help in test. We have not had a lot of involvement from the test part of the EDA community. And if you have any contacts there who'd like to play, we'd love to get in touch with them and see if that's something that they could
I might see who I can beat into coming.
That would be great. Yeah. We're starting, Jawad here is starting, and he's going to talk about it tomorrow, this notion of describing chiplets in a way that's friendly to EDA tools and processing them through that. Yeah. All right. So one of the biggest questions we had in the last panel was security. How are you going to get you get a malicious chiplet from some company that's going to basically screw up your system? And one of the more intriguing questions was, even if your chiplet's open source, it comes with a little extra on top. So it works the way it's supposed to when it's doing the functionality it's supposed to, and I think Brian's put some thought into that.
Yeah, or what could it be, right? I mean, so you've got, like you said, it's like, what does that flow look like when you start to open source some of these chiplet models, right? And so I think it's up to the consumers as well as the IP providers to help develop what that flow looks like. I mean, open compute in my mind, over the last few years, a lot of it was around, sheet metal and form factors and things like that. And it's really maturized, over the last, let's call it, couple of years. And it's now starting to include open source RTL, right? Which is a relatively new concept to me specifically. This is not something that IBM has done, historically in the past. But on the software side of the house, right? I mean, it's been done like this for many years within Linux. You're seeing this with the CHIPS Alliance, right? So if you're looking for the participation of folks dealing with open domain hardware, the CHIPS Alliance is a classic example of folks that are trying to play in that particular sandbox, and I think they're having some success there. Obviously, ODSA is a prime example, and we're trying to get that going as well. If you look at what's happened within the last few weeks, for example, IBM has changed quite significantly in the open hardware model. So a couple of weeks back at the Open Power Summit in San Diego, there's a couple of key announcements. I don't want to do this as a plug fest, but this is really just a kind of an endorsement of how things have changed within the last year or two. Open Power moving over into the Linux Foundation, moving from an ISTO model into the Linux Foundation, is a significant change in the endorsement of what open source looks like. Opening up the Power ISA, like you mentioned, Boppy, before, and Anton Blanchard doing a simple scalar fixed point ISA model and contributing that on GitHub, something that was, historic for somebody like, in the hardware business would have never done a few years ago. Also, the open sourcing of a few different, the open memory interface, as well as the open CAPI initiatives that IBM donated out there on GitHub, and doing FPGA reference designs, and folks looking at, absorption of, open source hardware models, right? Those are things that are dramatically changing. And I think what needs to kind of catch up is like everything that needs to be done with chiplets. So you've got all this great RTL and things like that that's being put out there, but you need the chiplet part of it to come into play and get standardization around that. Otherwise, it can only go so far. So if you go to the next slide. So what are the folks in the chiplet domain, what are they looking for? So one of the big questions I think that came out of the last ODSA that was addressed is, what does it mean to be a trusted chiplet, and how do you create a trusted chiplet in a catalog that people can basically consume? They want to make sure that if they're a consumer of chiplets, that there's nothing malicious about those chiplets. So what does that mean? One of the things that is out there in the industry, and I don't want this to be an open CAPI plug or anything like that, but one of the things that's out there today is like, well, how are you addressing that? Do you have physical addresses that are running around in your chiplets? Or are you doing things at a hypervisor level, or things at a virtual addressing level to make sure that all that stuff is secure, right? And that's an important consideration that, yeah, you put all the standardization around SerDes and interfaces, but you got to make sure that everything that's being done in your chiplet is being done at the appropriate access level. Mm-hmm. Otherwise, you put this in your system, and then you get all these guys doing nefarious things to your chiplets, and kind of game over. And so when you get into Facebook's problem of, okay, yeah, we put this chiplet in our data center, and all of a sudden it's being hacked like crazy, right? These are the things that these guys gotta worry about. So that's one of the things that I think that this community is just kind of at the starting level of, right? And we need broader participation to figure out what it means to be a trusted chiplet. And we kind of talked, this is just basically a slide that I stole from OpenCAPI, but the ability to run at a virtual address space, that's one way to attack the problem, right? So everything is done through looking at your page tables and things like that within your processor. So if you can manage things at the appropriate level, at a hypervisor level or virtual address level, that allows that trusted chiplet to basically come into play, and you're managing your chiplet at the appropriate software level, right? And so that's what, folks that are putting chiplets in their data centers, this is something that they have to seriously consider to make sure that, even though you're putting accelerators out there, that they can't be nefariously, hacked. Why don't you move to the next slide, Boppy? This is very much a very simple, trusted chiplet thought process, but, Kevin was talking about it, is like, so we need to work out this from a consumer level and an IP delivery model level. So what does it mean to be trusted? And there's different ways to do that. So what is a chiplet delivery mechanism? Is it source, like 100% source? Is it some source, but some of it's secret sauce because they don't want to necessarily share that source? Is it encrypted source? Are there system C models that go along with those chiplet IP models? Are there test bench patterns that you would like to go along potentially with those chiplet models? Or you could even take it down to the physical design level where you basically create an oasis shape, right, from the source, and you kind of know what that shape looks like. And if somebody does something nefarious, they're not going to do it in one or two little things. It's going to take a little bit of logic to create that malicious model. And if you create an oasis shape from that piece of IP, right, you kind of look at it and go, that's not really what it should look like, right? So you can basically kind of do physical design inspection before you actually go into silicon, right? So maybe there's opportunities to take it to that level to figure out whether there's malicious things that are being delivered or not. We've actually done something similar to that before. Obviously, We've got import-export rules with certain countries around the world, and we actually created, we had some source RTL, we created OASIS shapes. It came back, with some modifications, and we knew what it kind of should look like. And if it doesn't look like, what we expect, then you kind of just raise a red flag, and then you can figure out what your next step might be. So I think there's different levels of trust that can go on. Like, I think there's simulation things, I think there's test things, there's probably physical design things, there's hypervisor things. So I think there's a broad range of the stack of what trusted means. And so you got to basically attack it from another battery running low. You can attack it from many facets, but if you're going to put a chiplet in your data center, you got to make sure that it's trusted. And like I said, it can take many angles that you can actually do that trusted model.
That's impressive that our panel discussion has killed 2 laptops so far.
Yeah, that's impressive.
That's just like brilliant. But these are Dave's slides, like he knows
got to
them inside
memorize
out.
them. Anybody have any questions? Does that kind of make sense?
Do you have a power supply in there? I'll go ahead and use it. So, nobody has any security concerns? Maybe it's like,
Or it was such a good pitch that it just all, here comes Aaron.
there you go. We got.
I beat you to the microphone. So just a quick one on the security you just talked about. You suggested that people might provide RTL. Would you not, if in a particularly secure, if you're worried about security, wouldn't you just take silicon?
No, I think that's the problem is if you just take silicon verbatim, I think that's where you're ripe for actually getting some malicious behavior, right? To assume the guy on the other end is just some good, outstanding citizen and just taking their silicon, I would throw that right out of the door, personally.
Yeah.
So I think there's actually, the more set of eyes that are looking at the source and making sure that it's trusted all the way through the whole, let's call it development cycle, all the way to getting into silicon, I think that's something that you're going to need to do. Because I can guarantee you, if I told Facebook, I've got a piece of silicon out here, why don't you just go ahead and just trust me, right? It's going to be trusted. Don't worry about it.
Well,
Facebook wouldn't even.
It's not just that. I guess you're buying it from them, aren't you?
What's that?
You're buying it from them, aren't you?
Yeah, but I think,
But yes, you'd have to do your own diligence on that.
Yeah,
silicon.
exactly.
Yeah.
What I find really interesting about this conversation, I'll put forth, I am not a security expert. That is not one of the domains I listed expertise on in my bio. Back in February, Aaron said, hey, can you come to Samsung? We're having this ODSA workshop thing. And I said, what is that? And I walked out of that workshop really excited because what I saw is all the challenges that we're dealing with right now at the system level directly apply to the SIP level. It's interesting that you're utilizing an open cap. To me, it's interesting. They're utilizing an open CAPI slide, an analogy, which that slide was developed to solve system level problems.
Right.
At the hardware level or the software level or application stack level. Those concepts and techniques that are being developed directly apply here. Whether that be root of trust, secure supply chain, virtualization, how you control addressing. This effort leverages all that knowledge and capability in the industry. And we're solving similar problems at the system level that we have to solve at the SIP level.
Very interesting topic of security on chiplets. So I have a question. How do chip suppliers solve this issue today? And what can we learn from that?
Because, I mean, the other thing that you have to remember, right, with these open source contributions, right, so, one company might come in and they're providing a chiplet, right, but it's also, when you're working in an open source domain, other folks might also want to make contributions to that as well, right? So you can't just, there's got to be a kind of a checks and balances kind of thing when you've got a broad collaborative environment, right, because it's not controlled, right, in the sense that, if you're getting a piece of ASIC silicon from Intel, for instance, you know that it's very controlled exactly what they're doing, When you're working out in an open, collaborative environment, right, those same checks and balances don't necessarily apply, right? Because you're not sure if that open source contribution is coming from some kid that's working in his garage, right? Or some guy that's working from some small startup. So you've got all the spectrum of folks that are trying to innovate together. So you got to make sure that there's checks and balances all the way through the process to make sure that if we're all going to do this together, that there is a flow to make sure that it's trusted all the way throughout, right? If it's something that's coming from one specific company, right, that's kind of a different environment in my mind than kind of an open source kind of environment.
Great, thank you.
So if you've hung in there till now, Dave is going to tell you how to make money with the right chiplets to build.
Great. Next one, please.
Okay, DJ has a security.
Yeah, I wanted to ask a question on the security. So,
you want me to go back?
That's okay.
It doesn't matter. Yeah.
Okay.
So OCP itself has a couple of initiatives where companies are looking to solve problem of security in a holistic fashion. Are you envisioning at any point working closer with these initiatives or having ODSA have its own security initiative to solve?
Question. I don't know if, because that, like you said, that trusted question came up at the last ODSA. So the question is there a broader initiative where you want ODSA and OCP to kind of collaborate together, Bobby? I'm not sure what your vision is. I can imagine it happening, but I don't participate in the OCP trusted stuff.
My usual answer is look for someone brighter than me and do what they tell me to do. So
it's an interesting question. I'm glad you brought it to my attention. So I think that's something that I need to look into, to be honest. Like I said, this trusted question just came up like a couple of weeks ago. But I think it's a broader based question that all of us have concerns with. So we got to make sure that we're leveraging all the other communities if they're solving, a similar interest or similar problem. So thanks for bringing it up at least. So at least I can start to take a look at it. That's,
yeah, that's fair. So for the audience, that there's a RISC-V Foundation effort and looking at security for the processors. And I think overall the smarter thing to do is just find a way to slide into one rather than inventing your own new one.
Yeah, totally, 100%.
Dave?
So Bobby put this question to me of what's the best IP to build a product around? And I immediately thought of something like that's shown on the screen here, that you would have some high value IP that you have some great ability and value to provide here, something that might be like a smart NIC. That you've got some great functions for encryption or load balancing or machine learning architecture that you have. And so that would be kind of your IP in the middle, and then you need connectivity, you need memory, and that you might use chiplets around the side of it. And there's a couple other ways to look at this as well. I talked to this person who's developing an unpublished report on the number of chiplets that it would take to satisfy all the connectivity needs of military US government systems out there. And the number they were coming up with is single digit. And if you collapsed certain cases that he had, like PCI Express Gen 4 with Gen 3 and DDR3 with DDR4, the number gets down to low single digit. So there's another class of IP, which is these standard connectivity chiplets, PCI Express, Ethernet, and maybe your contribution there might not be that you do 10 gig Ethernet better than anybody else, but maybe you know how to manufacture this cheaper or develop it cheaper or faster. And then finally, there's a third case I was thinking of where the actual connectivity is extremely valuable and non-standard IP. I was talking with Scott Powell, who's right in our audience here, who's developing a very high performance ADC DAC that's one of these peripheral data source, data sync chiplets Another company is building a photonics chiplet. So these are ones that are very high value. So there's kind of 3 different cases of chiplets. And then there's this category of memory, which has similar cases of things that are standard, like DDR4, but you might build one that talks to GDDR6 or MRAM or some other exotic memory. Now, that case was that you have your IP in the middle or on the periphery. There's another case that actually is working out. It's very interesting. This picture on the top here that's got the FPGA and your sidecar accelerator is a configuration that one of our top wireless customers has used for years, of having their own ASIC next to an FPGA. They put their known functions in the ASIC. They put the things that aren't yet standardized or might evolve into the FPGA. That's a great model. The one at the bottom here that has this accelerator in line, this is an idea we've been talking to a major data center customer about, where data might come in off Ethernet. Some functions that they understand very well, certain compression algorithms that are well established go into the ASIC, and things that are not as mature, things that are still in development, such as deep learning, might go in the FPGA. So that'd be a case where your IP could be in the middle of a pipeline that goes from connectivity into some more general purpose processing SoC or FPGA. And you see the little picture of the Intel Agilex there even had a spot in our marketing of some other chiplet that might be up against the FPGA. Now, the other question that Boppy posed to me was, how can you participate with a solution that's too large for any one company to handle? Well, the fact is that every problem that's interesting is too large for any one company, even Intel. And I've got a couple examples here. At the top is a company called IR Labs is developing this photonics chiplet that goes up against an Intel Stratix 10 FPGA. You have to partner up. This is a great example of partnering. The next one here is the one I referred to before with Scott in our audience here, building a high-speed ADC DAC. That you need to partner up. And it's at any position along the integration chain, not just the device integrator or not just somebody with chiplet IP. Even the end user necessarily needs to partner up with the application developer, the system developer, the integrator, and potentially the chiplet IP developer. So I think the solution to this problem has to be partnerships, and that's a key way to participate in the market. If you've got some fantastic IP, find a good partner to work with that'll help you bring this to market. So, folks, that's everything I prepared there. Any questions?
So you think if you have new IP, like 10 years from now, the easiest way to deliver it is going to be a chiplet, if it's not as part of on an FPGA? Is that going to be a way to lower your costs?
We just announced this week PCI Express Gen 4 capability on an Intel FPGA. And the way we did that is we built a chiplet with Gen 4 that was just announced, and it's paired up to our Stratix 10 that was taped out 3 years ago. So this is just this fantastic validation of the chiplet concept of here we get a refresh on our existing in-production FPGA with some brand new PCI Express technology that that drops in to the existing set of silicon and packaging. And I can see that this model might continue 10 years from now.
So it extends the shelf life of an existing
You did it at the pipe interface, I'm assuming, right?
It was actually done at the AIB interface. So it is a full-on chiplet. Okay. It's a Gen 4 chiplet, AIB, then it talks to the FPGA.
Okay, cool.
Yeah, thanks. Just a quick one. Thanks, Dave, for the plug. But this is a great example, and this is really not so much as a question, I guess, as I'm interested in hearing your thoughts on this, everybody's, because when I look at this, there's sort of a couple of different competing areas. For this particular project right here, for my company, the best thing we could have is an interface that looks just like a wire. We don't care about anything else in there.
We got a deal for you.
What's that?
Have we got a deal for you?
Yeah. but I can see where if my chip were not, something that looked more like a transceiver, an ADC DAC, if that were a, tensor processor or something like that, I'd want that interface to look more like, some higher level protocol, maybe with some ACK-NAC and all that sort of thing. And I'm not, is the goal to try and get one interface, or do we think it's possible to get one interface that can serve both kind of extremes there? Or what's the thinking along those lines?
Scott, let me answer a slightly different question. I will talk about this tomorrow when it comes to the work group on link layer protocols. We've had a broad group of contributors there. The applications drive protocols, not the other way around. And so there's a huge span of applications, from a data streaming device where every cycle you get a piece of data, all the way to something where you really do care about a coherent memory view, both from the chiplet side, the processor, as well as the CPU side. And that requires a much more sophisticated full-on protocol rather than just data transport. I think we're going to see that kind of diversity that will continue, absolutely at the protocol level, and it might even at the die-to-die PHY level.
Okay. Any closing thoughts?
Chiplets are great. Help us out.
Come join the effort.
Does anybody have a question to close us off? Peter, do you want to do the honors and give us one last question to say?
So how can we join and work with you?
There you go. That's a kind of.
That's a good question for Bapi. He's our master of ceremonies in so many ways.
We'll take all the help we can get. The ODSA wiki has the 0.7 proposal. It's got all our activities. And it also has contact points with all the names, all the people who are, and what they're doing. We meet weekly. Each working group meets weekly. The PHY group meets once. The bunch of wires group meets like every day now.
Every day.
The link layer group meets once a week. The BOC meets once a week. So everything. We've got about, I counted it out, 20 active contributors. So more is better. With that, to our panelists, thank you so much. To our audience, thank you.
Thank you. You're a great audience.
You hung in there. Thank you.